Hi, this is Saka, and this is the regular Chem 10.5 homework. Okay, so let's go ahead and let's get started on this one. Let me get my little scribble pad out. Oops, that's from the last podcast, so let me get rid of that. Oh, there we go. All right, so let's go ahead and get to business here. So in question one, we have a 250 milliliter piston experiences 125 kPa pressure. The piston expands to 0.5, and so here we have, let's define our variables here. So we have V1 is equal to 250 milliliters, and then we have P1 equal 125 kPa, and we have V2 equals 0.5 liters, and we're solving for P2. Now the trick for this one here is notice how the liters and milliliters aren't the same. So remember, to convert milliliters to liters, we divide by 1,000, okay? And that'll give you the number in liters. And let's say you didn't know which gas law to start with. You can always start with P1 V1 over N1 T1, P2 V2 N2 T2. And you can see what's missing. So we didn't have any N or T, so this is Boyle's law. Okay, so that's question one. Let me erase so you don't get confused with what's going on with question two. So with question two, come up. All right, so for question two, we have a piston, and again, because this is in liters, I know that's V1, so 5.00 liters. The temperature, since it's in Celsius, is 23 degrees Celsius. We don't know what the new temperature is, but what happens when the gas is compressed to 2.00 liters. Okay, so this one, again, if we go ahead and do what we did before, we know that this is Charles's law. So V1 over T1 equals V2 over T2. Now remember, with this T1, you have to convert it into kelvins by adding 273. And your answer for this one will be in kelvins also. Okay? All right. So here's stuff from the stuff we did today. We didn't do not all these were demonstrations that we did today, but today we did the can crush. We talked about what that one was. If I heat a flask with a balloon, it causes it to expand. So think about what law that is. Can of soda explodes, and hairspray cooling down as it is used. So remember what each of these laws are. So Charles's law is V1 T1 equals V2 over T2. Boyle's law is P1 times V1 equals P2 times V2. And for Gay-Lussac, it's P1 over T1 equals P2 over T2. So remember, the can crush, we're looking at, we talked about that one in class. If we're heating a Erlenmeyer flask and the balloon's expanding, so volume is changing and temperature is changing, right? For the soda that explodes, that's temperature. And think about what else that is, because the other one gives it away. Hairspray cooling, clearly it's temperature and then something else as well. So think about what those are. So I don't want to completely give it away, but hopefully those hints will help you. Moving on to number 4. Excuse me. So for number 4 here, we have the 2.3 liter piston. That's V1. This is T1. So 50.5 Celsius, and this is T2 because it heated from this to this. If this is the piston at this kind of idea, so this is what V2 is. And we want to know what the pressure is if this is P2, because it's now 375. So we're solving for P1. Okay. Notice that there's no mention of N, so this is combined gas law. So this is P1 V1 over T1 equals P2 V2 over T2. Remember, these have to be in Kelvin before you put them into this equation, okay? Which of the reasons is it harder to breathe up in the mountains? Remember, the higher the elevation, the less gas there is, and it's lower atmospheric pressure. So if the pressure is lower, that means that there are less particles of gas at the higher elevations, and if there's less gas, you can figure out why it's harder to breathe. Okay, so let me erase and move up. Whoops. And so here's questions 6 and 7. So this one is a conversion factor, right? And so hopefully you guys are good at this now. Remember, 101.3 kPa equals 760 torr. And hopefully that's enough to kind of get you through. Remember, we start with this over 1 and then we multiply. So we could use this in times, and then on the bottom would be kPa, and so you can figure out which numbers go where. In the last one, here we have a V, we have a T, and we have a P. Now it's asking for grams, right? So this is amount of gas, and so what it's really asking for, this is indirectly asking for N first. Okay, so what we're going to do is we're going to use ideal gas law. See how there's no V2, T2, or P2? That's how I know this is ideal rather than one of the other laws. So PV equals nRT. We have our V. Remember, T we're going to have to convert to Kelvin. We have our pressure, but remember our pressure needs to be atmosphere, so we need to convert this into ATM. And R, remember, is 0.0821. And so remember, to convert this, you got to add 273. For the pressure, remember, you're going to have to multiply this times 1 ATM over 101.3. Sorry, let me write that again. 101.3 kilopascals. So that converts your pressure. You have your R. And now you can solve for N. So N equals PV over RT. Then once you find N, you're going to multiply N. So second thing you do, so this is step 1. Step 2 is you multiply, apply your N by the molar mass of CO2. Remember, to find the molar mass, you need the periodic table. Okay? Look up the mass of C and then add it to the mass of 2 oxygens. Okay? And that'll give you your right answer. So I hope this helps. Good luck, guys. And I will see you tomorrow, and we can talk more about this in class.